Good evening, everybody, and welcome to our video on transformations. This is going to be a real brief and very informal introduction to the concept of transformations, and then we're going to spend a couple days talking about this more in class and doing some more examples. So tonight's just an introduction, no examples or anything like that, and then we'll work on this a little bit more in class. So when we created our library of functions the other day, we looked at the most basic forms of all of those functions. And sometimes that basic form you're going to hear referred to as a parent function. So when we were just graphing things like f of x equals x squared, that would be the parent function of quadratic functions or square functions. Okay, so you might hear that term thrown around a little bit. So that was the most basic function. What we're going to do is take those basic functions in their equations and their graphs, and we're going to change them around. And we're going to start to write these equations in forms where I can quickly look at that equation, and I can tell exactly what changes I'm making to that original parent function, to that original graph, and then I'd be able to sketch that graph pretty easily. The changes that we're going to be making to these functions collectively are called transformations. So let's explore what the different transformations are. So basically, transformations can happen in two ways. We're going to change our graphs horizontally, which would be along the x-axis, or vertically, which would be along the y-axis. Okay, so basically left to right or up and down. And the transformations will be one of three different changes. There'll be shifts, which you might also hear called translations. That would be the formal term. So they might be called translations. Stretches, which you might hear called dilations. And flips, which you might also hear called reflections. So we're going to take these parent functions and those basic forms of the graphs, and we're going to shift them left or right along the x-axis or up and down along the y-axis. Then we're going to stretch it left or right or up and down. And what we mean by that is, let's say if I have a parabola, and let's say that's the basic parent function, I'm either going to stretch it and make it a little bit wider like this, or I can stretch it and make it skinnier to look like this. Okay, and so we'll explain that a little bit more in detail. And then flipping it left or right or up and down. With a parabola like this, it's kind of hard to tell if I'm flipping it left or right because of it's symmetric right in the middle. So if I were to flip this around, it would look exactly the same. So the left to right flip is kind of difficult to see, but the up or down flip, so if I were to flip this downward like that, it would be pretty obvious, right? So if it opens down, so I flip that down. So these are our changes, and they're all going to happen left to right or up and down, even though sometimes it might be hard to see, but still we can write an equation so that it flips this left to right. It just might be hard to see in the graph. Okay, so we're either shifting it or sliding it or translating it. We're stretching it or dilating it, or you might also see it written as compressing it. And we're also flipping it or reflecting it, left, right, up, or down. So let's look at our different parent functions and their transformed versions. So if you look at this list here, we have all our functions from the other day, leaving off the constant function. But we have the identity function, square function, square root. Extend this here to make sure that that x is underneath there. The cube function, the cube root, the reciprocal function, and the absolute value function. So here are all the basic ones where it's just x. Now over here is the transformed version. So you're going to see A, B, H, and K here. And in this case, these four letters are representing real numbers. So A, B, H, and K are real numbers. So when we see a transformed version with numbers in these specific places where A is, B is, H is, and K is, they're going to make specific changes to our graph. So Let me just extend this a little bit here and here. Okay, so wherever I see this A, whatever number is there, A is always making the same change, and we'll explain these in a second. B, whatever number is there, is always doing the same kind of thing to this graph. H is representing the same kind of change, and K is representing the same kind of change. So note the placement of each letter, because that's important. B and H are what I like to call inside the function. So if I'm looking at this, they're always like inside parentheses. So the B and the H are inside the squared part of this function, or here it's easy to see the B and the H are both under the radical, so they're kind of inside there. Here they're inside the parentheses again and getting cubed. Here they're underneath the cube root. Here they're down in the denominator. In this one, they're inside the absolute value bars. So they're with the x. They're what I would also call attached to the x. So they're inside there. So that means, thinking about our two different types of changes, they can either be horizontally or vertically. Since this is attached to the x, we're thinking about x-axis, so they're going to be changing our function horizontally. And then the k and a are outside of the function, so they're disconnected from the, or separate from the x. So I'm going to know that they represent our vertical transformations, right? So they are going to affect this graph, how it moves up and down, rather than the B and H, which represent how they change left to right. So now thinking about this, the A, the B, the H, and the K, they all do different things. So let's talk about what they do. So each transformed version, the following letters signify the following transformations. So A represents the vertical stretch and vertical flip. And what we mean by that is the vertical stretch. What we do there with A is we're going to multiply each y coordinate of the basic version of our graphs. So each y coordinate of the basic version by A. And that is going to take our graph and stretch it either up or down. And I know that it's going to be stretched up if A is greater than 1, and it's going to be stretched down if A is between 0 and 1. So that means, if, in other words, if A is a fraction. Okay, so what we're going to be doing then, since we were multiplying each y coordinate by A, and A is a fraction, like I would multiply a y coordinate by half, that would shrink it down halfway closer to the y-axis, or the x-axis, I should say. So we multiply each y coordinate of the basic version by A. So if we want to sketch a graph and we have this equation in transformed version, I would just multiply each y coordinate in the basic version by whatever number A is. Now the vertical flip, or the reflection, so this is going to be if A is less than 0, another way to say that is negative. So if A is a negative number, then we reflect over the x-axis. And that might be confusing because we're thinking, well, this is supposed to represent our vertical change, but remember, and even though I'm using the x-axis here, we're reflecting over the x-axis, so that means it's flipping from opening up if it's a parabola to opening down. So if A is less than 0, reflect over the x-axis. And I should say, if A is a fraction, you could say the absolute value of A is between 0 and 1, so that would be, if A is a fraction, then we're going to be shrinking down. Okay, the horizontal stretch, so when we're working with B, we will probably not see this very much because, first of all, like I mentioned above, the horizontal flip is a reflection over the x-axis. So again, if B is less than 0, we reflect over the y-axis. And so when I do that, since a lot of these graphs were symmetric, I'm not even going to notice that change very much. But again, If b is less than 0 or a negative number, that's where we're going to do our reflection, our horizontal reflection. Now, if b is, if we're doing a horizontal stretch here, what we're going to do is multiply, this is kind of where it gets a little confusing, each x coordinate by, so each x coordinate of the basic version, by 1 over b. And the reason for that is if this is a horizontal stretch, what we're going to want to do, the 1 over b will kind of represent that change of making this graph either skinnier or kind of wider. So whatever b is, we're going to multiply each x coordinate by 1 over b. So if b is a number greater than 1, this is going to make our graph skinnier. And if b is a fraction, the reciprocal of that fraction is basically what we're going to multiply each coordinate by, and that's going to make our graph wider. But like I said, you're going to rarely see this, so really up here in purple, that vertical stretch is what we're going to focus a little bit more on. A horizontal shift is going to be a shift left or right, and the thing to note is that just like when we had our equation for circles, up here I notice that this is always minus h, so it's always going in the opposite direction. So if I have something like x plus 3 in parentheses, that is going to be really a shift left. So horizontal shift, so this is going to be shifting left or right, and it's always kind of like in the opposite direction of what we see. Let me write out an example. So if I see something like x minus 4 quantity squared plus 3, h is really 4. So even though I'm seeing negative 4, I'd be tempted to shift to the left. This is really a shift to the right 4 units. Okay, so whatever's inside there, I would want to shift to the left because it's negative, but remember with the horizontal shift, it always is the opposite. So that's why I would shift right 4 units. For the vertical shift here, this is k, so it's always on the outside, and this is how we are going to shift up or down k units, right? So I'm going to shift up or down k units. So here, this plus 3, that would be a shift up 3 units. Okay, so I'm going to shift to the right in this case because I'm always going to the opposite direction, but with the k, I'm going to shift up or down just the way that it says. So if this is plus 3, that means I'm going to shift up 3. If it was minus something on the outside, then I would shift down, right? So if I have plus on the inside, I'm shifting to the left, but negative would be to the right, so counterintuitive, so opposite kind of what we're thinking. And then here on the outside, it's going to be up or down. Okay, so these are all the changes. So here, vertical stretch, and you might see this when I'm explaining this, which I'll give you an example in a second. I'm going to say, if I were to describe the transformation, I'd say that it's stretched by a factor of a, right? And that's because we're multiplying, and when we multiply, those are called factors, right? So when we're multiplying, if I'm going to write out this description, I'm going to say by a factor of whatever a or b are. So we're going to use this transformed version of each equation to sketch a graph, and we will be able to describe a set of transformations and be expected to write the equation in transformed form. So these are 2 examples that I want you to write down and I want you to try tonight, and then this is what we're going to start class with tomorrow. So first of all, write out a list of transformations and then sketch the graph of this function. So identify what kind of function it is, then tell me what transformations are going on, identifying what's a, b, h, or k, if all of those or any of those are present, and then go back and refer to this list at the bottom as to what kind of changes or transformations are going on. And then, so that would be sketch the graph of that. We'll basically figure out what function is, change the original parent function to reflect those changes. And then here I want you to try to write out an equation that has these changes made to it. So write out, identify what the parent function is and its equation in basic form, and then try to write the transformed form using these different changes or transformations. Okay, so bring that with you to class tomorrow. This is what we'll start off with reviewing, and then we're going to spend a couple of days practicing doing some examples with all of these. So have a great night, and I'll see you tomorrow.